Hey guys, in this video, I'll introduce you the exciting field of transparent shaping and its potential to revolutionize the way we use and interact with software. Transparent shaping was created by Dr. Sajadi in 2005. This video mainly is made based on Dr. Sajadi's paper, Transparent Shaping of Existing Software to Support Pervasive and Autonomic Computing. First, let's figure out what transparent shaping is. Transparent shaping is a technique for modifying the behavior of existing software to support pervasive and autonomic computing. In another word, transparent shaping is a model to make non-adaptive software adaptive. The key insight of transparent shaping is the synergy resulting from the integration of four key fundamental technologies: aspect-oriented programming, behavioral reflection, component-based design, adaptive middleware. Aspect-oriented programming is to enable separation of concerns at development time. Behavioral reflection is to enable software reconfiguration at runtime. Component-based design is to enable independent development and deployment of adaptive code. And adaptive middleware is to hide the adaptive behavior from the functional code. The goal of transparent shaping is to make software shaped to adaptive without disrupting the normal operation of the software for end users. Another keyword of this paper is pervasive and autonomic computing. Transparent shaping is a technique to support pervasive and autonomic computing. Then we also need to figure out what are pervasive and autonomic computing. Pervasive computing, also known as ubiquitous computing, is a concept in which computing technology is integrated into every aspect of daily life, such as in personal device, appliance, and environments. It aims to make technology seamless and invisible to the user. Autonomic computing is a type of computing in which the system is able to manage and configure itself without human intervention. The goal of autonomic computing is to create systems that can operate and maintain themselves in an efficient and reliable manner. Then, why we need transparent shaping? All these needs of pervasive and autonomic computing can be summarized to one word: adaptability. Adaptability is a crucial feature for both pervasive and autonomic computing, as it allows them to function seamlessly in various environments and changing requirements with minimal human intervention. Adaptability of software promises anywhere, anytime access to data and computing resource. So, to support pervasive and autonomic computing, we need software adaptive. This answers the question why we need transparent shaping. Transparent shaping is a technique can make software adaptive. Then, what is adaptive software exactly? Adaptive software is software that can automatically adjust to changing conditions without the need for human intervention. It includes features such as self-management, self-healing, self-optimization, and self-configuration. These features allow the software to automatically detect and resolve problems, optimize its performance, and adapt to different environments. And all these features are very important for organizations to quickly and easily adapt to changing business needs, technological advancement, and market conditions. Now let's make a summary. The reason why we need transparent shaping is that many popular programs are being ported to dynamic environments, but they are not designed to be adaptable. Transparent shaping enables dynamic adaptation in such programs and promotes reuse of software. Transparent shipping can make software adaptive to changing conditions and requirements without the need to modify the existing program's code directly. Then, how is transparent shipping working? The general approach of transparent shipping is to make small, unobtrusive changes to the code of existing software systems in order to enable them to adapt to changing conditions and support pervasive and autonomic computing. To be specific, generally, transparent shipping has two steps. Step 1 is to make the original program adapt ready. Step 2 is to execute shipping at runtime. An adapt-ready program is a program whose behavior is initially equivalent to the original program, but which can be adapted at runtime by inserting or removal of the adaptive code at certain points in the execution path of the program. These points, called sensitive join points. The difference for software before and after transparent shipping is there is adaptive code added into it. A non-adaptive software is shipped into an adaptable software. The adaptable software compromises the original program code that remains fixed during program execution, and adaptive code that can be replaced with other adaptive code dynamically. To make the original program adapt-ready, the first step of transparent shipping with interceptor refers to as hooks at the sensitive joint points. In the second step, execute at runtime. The composer uses hooks to convert the adapt-ready program into an adaptable program in the corresponding subfamily as executing condition warrant. Composer refers to the entity that performs the conversation, which might be a human, like a software developer or an administrator. Also could be a piece of software, like a component loader or runtime system. Here is a specific example of transparent shipping. This is a transparent shipping designing tree. The root of this tree, x0, is an existing distributed program. Children of x0, x1 and x2 are adapt-ready programs. The first step of transparent shipping is to put hooks into all the remote interactions of x0. Then we get an adapt-ready version of x0, which is x1. At runtime, if the system detects a low-quality wireless connection, the composer can insert adaptive code for tolerating long periods of disconnection into the adapt-ready program, which is produce x4 from x1. x4 is an adaptive version of x0 that can tolerate a low-quality wireless connection. If the user enters an insecure wireless network, the composer can insert adaptive code for encryption or decryption of the remote interactions into the program, which is producing x8 from x4. x8 is another adaptive version of x0 that can tolerate both low-quality connection and insecure network. Finally, when user returns to an area with a secure and reliable wireless connection, the composer can remove the adaptive code for both security and connection management to avoid unnecessary performance overhead result from the adaptive code, so the software goes back to x1. Depending on where the hooks are incorrupted inside an existing program during the first step of shipping process. There are three approaches to transparent shipping are identified. Hooks can be incorporated inside an application program itself inside its supporting middleware or inside the system platform, which could be a network protocol or an operating system. In Dr. Sajadi's series of papers on transparent shipping, he has investigated the first two approaches, where the hooks are incorporated either inside the application or inside adaptive middleware. So that's the main content of transparent shipping. Now we have a basic understanding of its concept. I'll make more videos about it. Thanks for watching. See you in the next one.